Hi, my name is Chris Cantak. Today we're going to do a deep dive into internet speed testing. I'm going to briefly describe what an internet speed test is, what gets measured, why those measurements matter, and what kind of results to expect in your own testing. In the second section, I'll be showing you several different speed tests. I've created a web page with links to over a dozen different tests. I'll provide that link in the description below as well as in the video. Finally, in the third section, I'll be going over some caveats and limitations of speed testing. Speed testing is a great tool for troubleshooting, but it's only one of many that you might need in determining a connectivity problem. If you're already familiar with upload and download speeds, loaded and unloaded latency, jitter, packet loss, single-threaded and multi-threaded testing, feel free to skip to the middle section of the video where I actually start running the speed test. However, I encourage you, even if you're experienced, to watch the entire video. I'm going to try to share some history and experiences of my own as I go through each topic. So what is an internet speed test? It's simply a tool that measures the performance of your device to a remote server and back. Of course, it doesn't have to be a remote server. There are such things as local speed testing, but for the purposes of this video, we're going to be focusing on testing your home internet connection to other servers out on the internet. There are three parameters that are in every good test. You've got download speed, upload speed, and latency. I'll explain all of those concepts in this video. Some tests also report what's called jitter and packet loss, and I'll discuss those as well. Because network conditions are constantly changing, rarely do you want to run just one speed test. If you're going to be doing some measurements, you want to run at least 3 tests, and preferably you would want to run those over a period of time to get a really good idea of what's nominal for your location. Note, these speed tests don't take any of your personal data or anything like that. How they work is they generate random blobs of data. They just slam random information down to your device, and your device creates its own randomized data that it sends back up to the server for the purposes of the test. This isn't just totally random data. It's data that's ensured to be non-compressible and truly random, so there can't be any sort of caching or other tricks going on to try to manipulate the results of the test. Now let's get into why we even run internet speed tests. Probably the most common time one runs an internet speed test is after they've gotten a new internet service provider or they've brought home new equipment. When my AT&T representative was out here to install my fiber, the first thing he did after he completed the installation was run a few speed tests, and he also had me run a few of my own speed tests. We were able to quickly verify that everything was fine. I'm paying for 300 megabit fiber service, and I'm getting about 375 megabits. Also, if you're going to be, if you bring home a new laptop, you buy a new router, you're doing something to your network at home, you want to run a few speed tests, preferably before and after, to verify that nothing's gone awry, that everything is working as it should. If you experience an issue or bottleneck in your network, a speed test is a great tool to turn to as a first step in troubleshooting the actual condition of your network. About 15 years ago, I had Mediacom as my ISP provider. Over the course of several days, I began to experience some serious buffering on YouTube. So I ran some speed tests, and sure enough, I was able to determine that my ISP had basically oversubscribed our network. During the prime time hours of 8 to 10 p.m., my speed tests were showing results as low as just 1 or 2 megabits per second, when in fact I was paying for the standard cable service at that time of 100 megabits down and 10 megabits up. I made sure that I ran my speed test directly connected to my gateway device. That way I was able to verify that it was a problem with Mediacom and not my own Wi-Fi network. Another example that has occurred just recently, for the past month or so, watching YouTube, I started to experience some buffering. And I hadn't experienced buffering for several years since going to fiber. Running some speed tests during these issues has verified that after running them from my Wi-Fi network and from running them directly connected to my ISP, I was able to verify that the problem was not with the ISP. I'm getting full speed from AT&T day and night, but indeed the problem was with my Wi-Fi connection. I hadn't made any recent changes to the network, so I did some testing further with some other Wi-Fi tools and was able to quickly verify that my next door neighbor who had recently moved in has set up some additional access points of his own. He was using the same channel as I am, and my speed results over Wi-Fi dropped dramatically during the times that he is also using his Wi-Fi network. By running speed tests both over my Wi-Fi and directly connected to my ISP, I was able to verify that it's a Wi-Fi issue with my neighborhood and not with the ISP or with the streaming service. And I would say the main reason why most people run a lot of speed tests is because of wireless connections. Whether you are talking about your own Wi-Fi environment, or perhaps you have T-Mobile or some other wireless internet provider, satellite, same thing. Those environments are most susceptible to variations in conditions. And they're the ones that probably most often need to be checked out to verify an issue. And it's always good to run speed tests on occasion when everything is fine. Because if you don't know what's normal, how do you know what's abnormal? So I highly recommend periodically running a speed test when everything is good. Learn to find out what is normal. And when I say what's normal, I don't mean just time of day and that type of thing. Your device matters. For example, I can be at home. I could have my cell phone and my iPad connected to the same network, and I'll run a speed test on my cell phone. And then after that's completed, I'll run a speed test on my iPad. Pretty much anywhere in the house, my iPad will get double the speed of my cell phone if it's connected to a 2.4 gigahertz network. And the reason being is because of the radio. All Wi-Fi radios are not created equal. My cell phone has a simpler single stream Wi-Fi radio for 2.4 gigahertz, whereas my iPad has a dual stream. It gets double the speed. Now, if I go to 5 gigahertz, what's interesting is my cheap cell phone and my iPad are then equal. They can both pull in 375 megabits on my local network over Wi-Fi at home because apparently the cell phone and the iPad have equivalent radios at 5 gigahertz. It's just, you need to always factor in the device just to know what's normal for your device before you jump to any conclusions. Okay, let's talk about download and upload speed. Download and upload speed are usually included in every internet speed test. I don't particularly like the term speed in this case. Actually, what we're talking about is the data throughput or overall capacity of your internet connection. A good analogy is a water pipe. A typical residential home might have a 3/4 inch water pipe that can provide 6 to 12 gallons per minute, whereas a larger home might have a 1-inch water pipe that gives you 10 to 20 gallons per minute. That capacity gallons per minute for water pipes is similar to what we call megabits per second for internet speed testing. One of my pet peeves is that so many videos I've seen on YouTube quote speed test as megabytes per second, when in reality we're talking megabits per second. And there's a big difference between the two. Roughly a 100 megabit per second rate is really more like a 12.5 megabyte per second rate. In terms of real world throughput, though, you're better off just dividing your bit rate by 10 to get a better estimate of what your bytes per second are. So if you have a 1 gigabyte file that you're downloading on a 100 megabit connection, figure it's going to take around 100 seconds or just around 2 minutes to get that file completely downloaded. Note that in technical literature, megabits per second is represented with a small b with various different representations. If you see an uppercase B in any of the abbreviations, then you're talking bytes per second. For many years, most cable interconnections were standardized on around 100 megabits per second down and 10 megabits per second up. Nowadays, the base level cable is typically 200 megabit down with 20 megabit up. Many cable ISPs offer up to 1 gigabit per second down, but usually there's still a significant limitation on the upload speed. Fiber usually provide symmetrical speeds. Usually they market 3 different tiers of service. 300 megabits per second will be your lowest tier. A mid-tier level will usually be around 500 or 600 megabits per second. Finally, you'll see a 1 gigabit per second plan. It is not unusual for some fiber ISPs to offer up to 5 gigabits per second, but plans exceeding 1 gigabit usually are extremely cost prohibitive. I think 99% of most consumers would be perfectly happy with the base level tier of 300 megabits. 5G wireless speeds will vary dramatically. Anytime you get wireless connections involved, you're going to be dealing with a much more variable level of service. In the case of a 5G wireless connection, for example, it all depends on how far you are from the cell tower. How strong of a signal can you get? Some people compensate by buying external antennas for their homes, and the quality and speed of that connection will still vary dramatically depending on the time of day. Because when you're pulling your internet off the cell tower, you're using a shared service with all the cell phone users in your area. 30 to 250 megabit second download, 6 to 35 upload is pretty typical for like a T-Mobile connection. As of this recording, Starlink currently offers 3 tiers of home residential internet service. They have a 100 megabit per second plan for small households, a 200 megabit per second plan is their mid-tier, and a 400 megabit plan that they call Residential Max. However, these speeds are download only. When it comes to upload, Starlink currently is limited to around 8 to 25 megabits per second, maybe a bit faster on the Residential Max plan. Starlink is working towards improving that. They're in the process of lowering some of their satellites. They've recently got FCC approval to up their power levels. I expect in the near future, you're going to see much better upload speeds from Starlink. Legacy geosatellite services such as Viasat and HughesNet are now virtually obsolete. While they do offer some reasonable download and upload speeds for their day, they've always been hampered by high latency, and we'll talk about that a bit more in a minute. Download speeds on these services typically range from 20 to 50 megabits per second, and an upload of about 1 to 3 megabits per second. But with the high latency involved and other options now available, such as Starlink and wireless ISPs, I don't think legacy geosatellite should be seriously considered by most consumers. Okay, the next metric we're going to look at now is latency. In some ways, I feel latency is even more important than the overall raw bandwidth or speed that you get. Essentially, latency is the response time of an internet request. If we go back to our water pipe analogy, think of latency as the time it takes for the water to start flowing once you turn the tap on. A more realistic example for the internet would be Google. If you're on a Google search page and you enter a search term, the time you have to wait for that search term to get to the Google server and for Google to start to process it and to start sending you data back, that wait time would be considered the latency for that search request. Latency is measured in milliseconds, so the lower the better, a millisecond being 1/1000th of a second. It's mainly influenced by the distance between you and the server. Anytime you're dealing with streaming a video, accessing Google or any type of thing like that, you're dealing with a server somewhere else on the internet. The number of hops and distance your request has to travel determines your overall latency. Latency values can vary quite a bit depending on the infrastructure and congestion on the internet. An extremely fast response might be in the 4 millisecond range, whereas 700 milliseconds is not unusual for someone that's on a legacy geosynchronous satellite system. Some speed tests will refer to latency as ping time. This is due to the fact that the ping command has been historically used to measure latency. What is considered good or bad latency depends a lot on the application. For phone conversations, Zoom meetings, anytime you're dealing with interactive conversations, you want your latency to be below 100 milliseconds. If your latency gets above that, say 150 to 200 milliseconds, the conversation is going to start to feel a little bit off. And at 250 milliseconds, which is a quarter of a second, you can start running into people talking over each other as they tend to interrupt each other. For internet gaming, low latency is far more critical. You really want to have your latency under 20 milliseconds if possible. Elon Musk, one of his long-term goals with Starlink is to achieve 20 milliseconds or lower latency. 20 to 40 milliseconds is still pretty good for almost any internet gaming situation, including competitive play. 40 to 60 milliseconds is starting to be a problematic range for competitive players, but still pretty acceptable for nearly all internet gaming. However, once you get over 60 milliseconds, your competitive players are at a definite disadvantage. Your best case latency, what you'll see on a situation where you're pinging a local server or running a speed test to a server very close by, will depend a lot on the infrastructure of your internet connection. Fiber can often be in the 4 to 12 millisecond range. There's a fast food restaurant near me who has a fiber connection for their internet. When I'm at that restaurant and I'm running a speed test on my iPad, I literally get a 4 millisecond latency response to the nearby server that Ookla hooks me up to. To me, that's faster than even anything I've experienced at home. Cable best case typically will be 12 to 25 milliseconds for their latency. 5G wireless like T-Mobile, Verizon, AT&T wireless, your latency can vary anywhere from 5 to 20 milliseconds. Once again, wireless is one of those environments where it's a shared medium, so depending on congestion and other conditions, the latency values can vary widely. Starlink tends to be in the 20 to 45 millisecond range. More and more, they're working down toward that lower end of 20 milliseconds where possible. Legacy geosatellite is the killer. That's where the latency values range from 600 to 700 milliseconds. We're talking over half a second of latency, and that is very problematic for a number of applications, including even web browsing. More and more speed tests are now reporting both unloaded and loaded latency. The unloaded latency is the traditional latency response, the ping time of a connection when your internet is otherwise idle or quiet. Loaded latency refers to the latency you experience when your network is undergoing some significant other activity. Maybe somebody else is streaming a video, someone else is doing some gaming. The condition that loaded and unloaded latency tries to identify is called buffer bloat. It's basically a measurement of how well or poorly your gateway device can handle multiple connections at the same time. Now I'm going to discuss two more metrics, jitter and packet loss. These two metrics are often overlooked on a lot of speed tests. Jitter is the measurement of variations in latency. That is, it's a measurement of how steady your internet connection is. If you're watching a streaming video, for instance, and internally the system is seeing a lot of data packets coming back quickly, but then others taking a long time, that variation in latency is what is considered jitter. It's measured in milliseconds. The lower the better. Anything under 5 milliseconds is considered excellent. If your jitter value gets to be 20 to 50 milliseconds, it could be problematic. Certainly over 50 milliseconds can be a problem. And what the type of problems am I talking about? I'm talking about things like choppy video calls or uneven response in web usage where certain things are responding quickly, other things are not. It's possible that you could even lose a VPN connection. Again, most speed tests do not report on jitter. Another metric that we don't see on most speed tests is packet loss. Packet loss is a measurement of data that's lost in transit. It's usually expressed as a percentage. Your internet connection will compensate for packet loss if it sees missing packets. Your client, your computer or cell phone, whatever your client device is, will go back and re-request any missing data packets, and it'll get everything sorted in the proper order. So most of the time you don't notice packet loss. Unless, of course, it becomes severe, then you're going to notice it as a slower connection. Generally, you're going to want your packet loss at or very close to 0%. However, certain connections like satellite, Starlink, and others could typically report a small percentage of packet loss. That is not really a problem as long as the numbers are very, very low. Packet loss can be influenced by faulty hardware or congestion or software problems, but most of the time, at least on the traditional internet connections that I've worked with, you won't see much packet loss. Now I'm through talking about the different measurements or metrics that we look at, but let's cover some terminology because we're just about ready to start the speed test. Speed tests on the internet are not all created equal. There's some that are known as being single-threaded and some are multi-threaded. A single-threaded speed test uses only one connection for the data transfer at a time. That is, one logical connection. It reflects real-world performance when it comes to things like web browsing. It can be a bit more sensitive to congestion and routing than a multi-threaded test. A multi-threaded test being one that uses many connections at once. Essentially, what multi-threaded tests are designed to do is to measure the maximum possible throughput of your internet connection. Going back to our water pipe analogy, imagine some sort of test that just tries to cram as much water down your incoming line as fast as possible. That's a good example of a multi-threaded test. Multi-threaded speed tests are probably what you want to run if you have a high-speed connection to your ISP and you really want to measure if you're getting your full capability. When I mean high speed, I'm talking about where you have a 500 megabit or a gigabit or faster connection. Okay, we're about ready to run some speed tests. I provided a web page that will provide access to all the tests that I show in this video. The address is https://cantac.com/speedtest/. You should be able to run these tests in most any web browser. They don't install anything, and they're not specific to any particular operating system. I'm going to demo now a number of these tests, and then we'll return back to the PowerPoint slides for just a few minutes on some follow-up information regarding speed test limitations and caveats. Okay, we're now at the web page with all the speed tests that we'll be using for this video. You're welcome to put this in your favorites and use it whenever you wish. I have it divided in sections here. The most popular sites are listed first. Some slightly more independent diagnostic speed testing sites are located in the second section. I've got some ISP hosted sites listed, and then even a couple sites I don't recommend, and I'll touch on those later in the video as to why I don't like these particular sites. Before we jump into the top here and work our way down the list, I'd like to jump over to the AT&T speed test. It provides me with two types of tests. In addition to a regular speed test, I can also run a equipment speed test. And what that is, it's a test that works between your gateway device and your ISP server, your local ISP provided server. It's a good test to run because it eliminates any sort of bottleneck or factor in your own network. If you truly want to know how fast you are connected to the internet, this is the test to run. I'm going to go ahead and run that now. Now logged in to my AT&T account. Notice the screen has changed slightly. I still have this standard speed test available, but I also have a start speed test button available to me under check equipment speed. I'm going to click on that, and we'll let that run for a second. Again, this test provides a direct link between my gateway device, my router, to AT&T. It should represent the very best case scenario for internet speed in my home. So here's the results. I get 398 megabits per second down and 397 megabits per second up on this particular test. Notice it lists my plan speeds here. It says your plan speeds up to 300 down, 300 up. Obviously, I'm exceeding that. Just a nice bonus with AT&T. On their lower tier plans, they typically exceed what they commit to offer. So excellent results here. This is very nominal. I can actually view my history too. If I click here, I can see what the results were recently. It's kind of hard to see maybe on your screen, but they're very consistent. The last several tests have all shown 398 megabits down and anywhere from 396, 397 up. So very nominal results here. This kind of just proves out that my connection to my home is working nominally. If your ISP provides a test like this, keep it in mind when you're doing any sort of troubleshooting. If you don't have this type of test available to you, the next best thing is to run any one of these other speed tests while you're directly connected to your gateway device. I'll go ahead while I'm here to run a standard speed test. I happen to be living in northern Alabama, so it's picked a nearby server called Cloud9 Internet in Lawrenceburg, Tennessee for this test. One thing I don't like about the AT&T test is that this graphic is kind of backwards. When it does the download test, it shows a blue bar going up to the server, and when it runs the upload test, it shows this blue bar growing towards my device. And obviously that's backwards from what the test is actually doing. This particular test shows 74 megabits down, 32 megabits up, and 13.9 milliseconds of latency. This fourth number isn't labeled, but I'm sure it's representative of jitter at 2.744 milliseconds. Now you may be wondering, well, there's a big discrepancy here between this result here and this test to a nearby server. That's because I'm on a Wi-Fi network. This does take into account my local network, and I happen to be running these tests out in my man cave. This is a separate building from my main home. I'm about 120 feet from my wireless router. Plus, I have, the signal has to leave this building, travel 120 feet across my yard, and then go into my house before it gets to the internet. That is why we're seeing much slower speeds. This probably represents a very good result for the conditions. I suspect that when we run additional speed tests throughout this video, we're going to see similar results or slightly slower than this. Normally, you would run multiple tests to get a true result. I would run 2 or 3 tests if I was trying to get a good median or average result. For the purposes of this video, I think we'll just move on. Now we'll work from the top to the bottom here of the websites listed, and we won't be going through each test in detail, but we will be touching on some of the highlights of each test available. Ookla. Ookla is the most popular site on the internet for speed testing. It's the site I use the most. They also have an application available for Android and iPads and PCs. I'm now connected via a VPN, so it's going to appear that I'm in the Houston area. The reason why I'm using a VPN service right now is for the purposes of this video. I don't want my home IP address to be known. When you first click to run a speed test on Ookla, if you haven't ran a test before, it's going to prompt you up here about wanting to know your location. I've not seen any difference in what selection I make. I don't know what that does. It still knows where you are because it points you to nearby servers. Note here, already completed the download and is now running an upload. We show 55 megabits down and 29 megabits up. It shows 3 different latency values. This is the idle latency at 30 milliseconds. This is a download latency of 232 and an upload latency of 112. That is, the 232 and 112 represent loaded latencies. Note here that they are significantly higher than the idle latency. And that's true for my AT&T gateway device. It does suffer from what is called buffer bloat, and you will see loaded numbers often significantly higher than the idle numbers. After the test completes, it gives you an option to rate your provider. You can also run additional tests just by clicking the Go button, or if you wanted to, you can click Change Server, and then we'll show you a number of servers in your immediate area. Because I'm using a VPN that comes out at Houston, I'm seeing Houston area servers here. Note AT&T has a speed test server in Houston. Let's go ahead and just run that. Again, because of my Wi-Fi connection, the very best I'm probably going to see is around 75 megabits down for a speed test. And the upload here is it looks like it's gonna clock in at about 29 or so megabits up. So that's pretty good. That's nominal for my Wi-Fi man cave connection. One thing that people don't realize with Ookla is that you don't have to use a nearby server. You could run a speed test to anywhere in the world. I can key in like Sydney or Sydney, Australia, and literally run a speed test on the other side of the world. Or go to Tokyo, Japan. So there's not a whole lot of reason to do that, but sometimes if you just kind of wanting to experiment, you could run speed tests from anywhere in the world with Ookla. Just kind of key in the name of a city or a server that you know, and if it finds it, give it a shot. In my own testing, if I run a speed test to Tokyo or Sydney or someplace like that, your latency jumps up to around 175 milliseconds, and your download speed surprisingly is not affected much. It's mainly the upload speed. I may only get like 6 or 7 megabits. There are really only two things I don't like about this website, and one of them is not even Ookla's fault. Because this site is so popular, it's often blocked by many public Wi-Fi access points. I like to run speed tests wherever I go. If I'm at a restaurant or a fast food joint or a grocery store that has Wi-Fi and I haven't tried it before, I might just for curiosity, I'll run a speed test. And because the Ookla site is so popular, they often do set up a specific block for this website. There are ways around that. A couple of things you can do. You can change your DNS pointer. Sometimes that works. But the best thing that I've discovered is just to run a different test. If Ookla is blocked, you can still usually get by running almost any other speed test, and you won't find those blocked. The other problem with the Ookla site that you won't see here in this video is advertisements. They surround this whole web page with ads. They are becoming really rather obtrusive. I have set up an ad blocker just for the purposes of this video. Normally, I don't run ad blockers at all. I'll watch YouTube with ads and everything. I believe in the free market system. But in the case of the Ookla website, they have kind of overdone it. And it sometimes takes several seconds extra to load the web page due to all the ads. In addition to running speed tests, Ookla has a lot of additional information available. They've got some guides here you can click on and read all kinds of documentation all about speed tests, the different properties and troubleshooting tips. A lot of good information here. If you're interested in more details about speed testing, by all means explore this site. I'll show you a screenshot of the results from an iPad test. This screenshot here shows snapshots from my iPad. Here's the results of a test, very similar to the website. I've kind of blurred out the advertisement here. And if you click on detailed results on the iPad, you'll get this screen here, which I really like. It clearly outlines your download, your upload, your ping times, both loaded and unloaded. And note here, you get packet loss, which is not available when you run it from the web. Because I ran this speed test from within my house, I got a much faster speed. Okay, there's just a few more items I want to cover regarding Ookla, the speedtest.net site. There's an option here to log in. It doesn't provide the average user any real benefit, but if you're really into speed testing, what the login option allows you to do, it'll save your results. You can look at history. If I go up here to results history and click, I get this graph of various speed tests that I've run in the past. Now, this graph I find kind of meaningless. I mean, if you look at it, it's hard to read. But what I do like is the additional data available, and you can export the data. You can click here, and it will save a file in your downloads folder. It's a comma separated values file. You can import it into Excel. It's nothing too fancy, but it provides you with download, upload speeds, latency, and even the latitude and longitude of your location. The other advantage of logging in is that you can run either a multi or single threaded test. Now, for my type of connection, which is not all that fast, you're not going to really notice any difference. I'm now connected to a Los Angeles area VPN server, so it's pointing me to a local server in LA. We'll run a quick multi-threaded test. And as I expect with my Wi-Fi connection, I'm going to get right around 69 megabits per second down. With an upload speed here, it looks like it's going to be around 27 to 28 megabits. It looks like it's going to finish out at over 30, 31 megabits up. The ping time here is 91 milliseconds. This particular server that we are running a test on is a little over 2,000 miles away, so that's not too bad. If we go back and run this as a single threaded test, notice the go button on the Ookla page changes to a yellow-orange color. I'll go ahead and run a single threaded test. I suspect we're not going to see a huge difference. I think we would see a significant difference if we were on like a gigabit connection. But on a slower connection like this, where I'm on a Wi-Fi connection that peaks out around 70 megabits, I don't expect this single-threaded test to really give us any different result. And sure enough, you can see here that we're getting around 67 megabits down per second and an upload speed of just about 32 megabits per second. So you can run both multi and single threaded tests from the Ookla website, but you may not notice a big difference depending on your connection. What I really like about Ookla is I consider this website to be kind of the gold standard when it comes to results. The numbers I see match up well with what I expect and with what I see at other quality speed test sites. Also, Ookla publishes a number of papers throughout the year that they freely give to various technical publications. They take all these statistics that they gather and they write some good technical articles providing results showing who's got the fastest ISP, what parts of the country get what type of performance, how Starlink compares with what it did before, things like that. They provide a lot of interesting technical details to the industry, and I appreciate that. Now we'll move on to the next test on the list, SpeedSmart. If you'll note on my webpage, I call it a reliable alternative when Ookla is blocked. The reason I say that is because I normally don't actually use SpeedSmart that much from the web. I tend to use it on my iPad. I have the SpeedSmart application installed there, and when I go around town and run a few speed tests, in many locations I find where Ookla is being blocked. So then I'll just turn to SpeedSmart and run a test from it. I have yet to find any location that blocks SpeedSmart. When you click on the link, it'll take you to a screen here where you can start your test. That you do have the option of changing your server. If you note down here, it's showing Oslo, Norway as the server it's going to go to. I've connected to Oslo, Norway, simply because I'm using a free VPN and I don't have a lot of choices as to where it's going to connect me to. But that's fine. It'll give us a chance to run some long distance speed testing, and you can see the differences in the latency numbers when you do it this way. So let's go ahead and kick off this test. I like the interface of SpeedSmart, both on the iPad as well as on the website here. It's a very simple, very clean interface, and they provide you with both latency and jitter, upload and download speed. And you don't get to see loaded versus unloaded latency, but it's still a good, reliable test. I find the numbers with SpeedSmart to be very consistent and accurate, very closely in agreement with what Ookla shows. If you notice here, the results of this test, it's 147 milliseconds of latency. Now that sounds high, but keep in mind that this particular server that I'm speed testing to is over 7,000 kilometers or over 4,400 miles away. There's a 4.9 milliseconds of jitter, nearly 58.5 megabits per second down, 20 megabits per second upload. So that's a pretty good result. If I were running on a local server, I would probably see slightly higher download and upload speeds, and of course a much better latency. But other than that, these results are quite good. You can change the server from SpeedSmart's website. Notice here it does offer you a number of servers. Now because we're coming out to the internet in Norway, it is showing speed test servers that are local to Norway. I like the way they show the distance. Like the server that I tested against is just 1 kilometer away from the VPN server that I'm using. If I wanted to test with Stockholm or Berlin or Amsterdam, notice it shows the distance in kilometers to those locations. The SpeedSmart test site offers much more than just speed testing. If you click on the apps, you'll get an overview of the applications they offer for iPhone and Google Play. I have used the iPad app extensively and it works very well. Again, I've never seen any place where the application has been blocked. Clicking on history will show you your historical results for the day. If you log in to an account with them, you can go back further on your history. I have not set up an account with SpeedSmart. This right here is showing my history for testing I've done this morning, all via the VPN connection I have at Oslo, Norway. What's interesting is you can click on any one of these to get a little more information as far as the specifics for that particular test. They don't show packet loss, but they show pretty much everything else. I like the fact that they show how much data you've used. This is especially useful if you're running this application on a mobile device. They also offer metrics, and this page just illustrates a bunch of statistics that they have gathered, both from cellular testing as well as local Wi-Fi broadband testing. They break down some median speeds by country. And so it's just kind of interesting stats if you're really into speed testing and what is available or how other countries compare with your own. If you click on the blog link, you're going to get all kinds of documentation about speed testing. They talk about why to take a speed test and understanding the metrics, and they provide you with various stats on connection speeds from various cities throughout the United States and latency numbers. And so it's kind of interesting stuff. Various providers are also looked at, AT&T versus T-Mobile versus Verizon. A lot of this is US based. SpeedSmart is a multi-threaded test. It reminds me a lot of Ookla in that when you can export your data if you have an account, and the spreadsheet looks almost identical with what Ookla offers for exported data. Before we move on to the next speed test, I just wanted to show you a couple screenshots from my iPad of the SpeedSmart app. Note it doesn't look much like the website. It's a little bit different layout, and of course there's no dark theme here. because I ran this within my house. Of course, I got the much faster Wi-Fi speeds. You can select the different server here, and that's really about it. It provides you with the ping time, the idle ping, a jitter measurement, as well as your upload and download speeds in megabits per second. Again, I find SpeedSmart to be an excellent site for a backup, so to speak. If I'm somewhere around town and I can't run Ookla, I just go to SpeedSmart and it works every time. Now we'll go down to the next speed test site, fast.com. Fast.com is owned and operated by Netflix. I'll tell you a little bit of history about how this site came about. Around 2015, a number of Netflix customers were experiencing buffering problems with streaming Netflix TV shows and movies. Now, Netflix had built out a considerable content delivery network, that is, on servers scattered throughout the country, and I'm speaking specifically of the United States, and felt that they really had a good service infrastructure for their customers. Yet their customers were showing great speed test results, but were having problems with buffering Netflix. So Netflix decided we're going to build our own speed testing network. We're going to take some of these servers that we're using for content delivery and we're going to turn them into a speed testing network. That way, our customers can run their own speed tests against our servers to see if the ISPs are throttling traffic from our servers. So Netflix built out the Fast.com speed testing system, and over time, Netflix was able to get favorable treatment from the ISPs. I don't think they have a throttling issue any longer. It's nice that Netflix had done this, providing their customers with a true speed test that would reflect Netflix traffic. You have to be a bit careful when you first navigate to fast.com if you're on a mobile device because it will immediately auto launch the download speed test. I'm going to go ahead and click on it here. I'm now connected to a server in Los Angeles, about 2,000 miles, again, away from my location. So the latency values are going to be a little bit high. The test doesn't take long. It's already completed the download here. It's showing 84 megabits per second. If I click on Show More Info, note here that it's still in the process of running the upload, but it's already completed a latency, an idle latency measurement of 55 milliseconds, which once again is very good considering I'm 2,000 miles away. And then here's the loaded latency, and that is very high, and once again shows that I have what's called a buffer bloat issue with my gateway router. I may do a separate video on buffer bloat sometime in the future. This upload is now completed with a 30 megabits per second result, with the exception, of course, the buffer bloat number, the loaded latency. These are excellent results for my location. I noticed that the Netflix speed tests tend to run quite well. They give you an excellent result, probably one of the faster speeds because they have so many servers located throughout the country. If you click on settings, you can change the behavior of the speed test. You can actually change how many parallel connections. By default, the Netflix test is multi-threaded, and it may use anywhere from 1 to 8 threads to run your speed test. But you can force it to be a single-threaded test or a multi-threaded test by changing these values here. You can also control how long the test will last. If you want to run a test for several minutes, you can bump these numbers up. I've never bothered changing these values other than saying down here to always show all metrics. That way, in future tests, I don't have to click another button to see the upload and latency. This will now run the download and then immediately show you the results along with the upload and latency as soon as they complete. This is a great test to run if you don't have a dedicated ISP test to run from your gateway to the ISP. What you do is direct connect your computer to your router and then run this test. Here's why I think this test is a good substitute if you don't have your ISP providing you a dedicated device equipment test. Note here I'm showing 390 megabits per second. This was done from inside my home on my iPad. And as you can see here, the results are very close to the 398 megabits per second that I was receiving from my dedicated AT&T device test. For the remaining tests that I want to discuss, I think we'll pick up the pace a bit. I'll just point out the highlights of each test, what makes it unique, why I've included it on my speed testing site. Cloudflare is one of the largest internet infrastructure companies in the world. They have over 300 servers worldwide that are providing content delivery network services, things like accelerating your web browsing, your streaming of videos. They also provide denial of service protection for companies, as well as many other internet security services. Many of you may be familiar with Cloudflare's DNS service. They provide what's called a secure DNS, where you can freely point your computer to their domain name system and use their phone book, so to speak, for the internet. When you click on Cloudflare, it will first come up with a banner asking if you wish to proceed, because they do capture some statistics and they're just giving you an opportunity to review their privacy policy. So that's kind of a nice feature. The fact that they talk about what they collect and what they do with the information. Cloudflare's very conscientious in that regard. And they also note that the speed test is going to consume up to 200 megabytes of data. And so that's another nice little warning to have. If you're good with that, if you're not on a limited data plan and you're not concerned about data usage, you can go ahead and proceed. Be aware, though, that subsequent visits to this website may just auto-launch the test. You don't get that start banner every time you come out to the site. The test takes a couple of minutes or a minute or so. Notice this animated rabbit up here running in the left-hand corner of my screen. Once that rabbit stops, then you know the test is completed, because it does alternate between running different size tests. Once the rabbit stops, you've got your final results. Here we're showing about 72 megabits per second down, nearly 40 megabits per second up. I'm showing latency of 69 milliseconds. Now, this is a server in Houston where I'm coming out onto the internet using VPN. I'm roughly about 775 miles from Houston, so that's an okay latency number. It also shows loaded latency, both during upload and download. You'll also see jitter here, and you'll see jitter idle as well as loaded jitter, upload and during download. And it does show packet loss. Most of the time when I run this test, I show a 0% packet loss, but this time we did get a little bit of 1%. That's perfectly nominal. If you're doing some other wireless test, say over T-Mobile or some other wireless service, don't be surprised if your packet loss is not 0. If you scroll down a bit, you can see the different measurements that were taken. They ran a 100 kilobyte test and both download and upload, as well as a 1 megabyte download and 1 megabyte upload test, and then a 10 megabyte down, 10 megabyte up. They also show latency. One thing I want to point out, this network quality score is worthless. I would ignore these. It'll say video streaming poor, online gaming bad, video chatting bad. This is really misleading and incorrect. Believe me, at 72 megabits per second, you can stream, and you could have multiple people streaming 4K videos with no problem. This is from my iPad when I ran the same web link from within my home. Note here, with much higher numbers, they're still showing a network quality score of good, average, or good and not great. And with speeds like this, you can do anything on the internet. You can have your whole family of 5 or 6 people doing things on the internet and would have no problem. So I don't care for their quality scores. But I do like the fact that they do offer complete figures. Notice here there was no packet loss, and they also showed the jitter, both loaded and unloaded. Once again, these are very rarely found on most speed tests. Okay, the next speed test we'll look at is speedof.me. About 12 years ago, I considered this one of my favorite speed testing sites. Now I've almost put it into the not recommended column, as it is a site that's just become quite dated. What made speedof.me a good site was that it was the first site that didn't require any sort of plugin. It was pure HTML5, and it didn't require Flash or some other internet plugin that was common for speed test at the time. If you come here for the first time, you'll be needing to accept the cookies, and then after that, you can start your test. SpeedUp.me, what I liked about it as well is that it runs a series of downloads. It starts with some small files, and then it gradually works its way up to larger and larger files, as you can see from this graph right here. Very similar to what Cloudflare does as well. Once it completes the download, we'll see it do the same thing with the upload. We'll see a yellow graph up here overlaying the download information. Once again, it'll do multiple file sizes for its upload test here. And now it's completed its result. This particular test shows a download speed of nearly 74 megabits and an upload speed of 35 megabits per second. Latency is 31 milliseconds, which is an excellent result for a server that is about 800 miles away. But that's about it. It'll tell you where the test server is, but you have no options to change your server. What is interesting about this website is that if you launch it from a mobile device like an iPad, you will get a different type of graphic. This is speedup.me from my iPad. You get the circular arc rather than the graphic that we saw on the website. And as you can see here, the latency was quite a bit shorter as I was running without a VPN. The test results are fairly accurate. I do notice sometimes there can be quite a bit of variation. Sometimes it will select a different server. If I'm running without a VPN, I usually get Atlanta, as you see here, but I've also seen Chicago or even Dallas, I think, on occasion. So it can jump around a bit depending on what it feels is the best server. But there's no real choice in what server you get. It doesn't really offer anything in addition to what you see here. That's speedup.me. Now we are going to visit one of the most open and transparent speed test sites on the internet. It's called LibreSpeed. What makes LibreSpeed unique is that it uses no secret protocols or any sort of proprietary code. It's fully open sourced. It uses standard HTTPS requests to run the speed test, so it very closely mimics web browsing performance. The downside of all of this is that it may underperform on high-speed networks. If you're looking for super fast numbers in your speed test, this isn't the site to go to. This is more of a real-world web browsing type performance test. Switching over to the computer now, I'll click on LibreSpeed. It loads a very simple interface. It'll default to the nearest server it finds to your location. At the moment, I'm on a VPN connection to New York City, so it's defaulted to a server in New York. If I click on the down arrow, you'll see a generic list of other servers in the United States and really around the world. There's a very limited selection. There's not a whole lot of servers here. I'll click on the Start button to run the test. And what we'll find here, I think we'll find a good performing test for my Wi-Fi connection here out in my man cave. These are perfectly normal figures. I see a 72 megabits download and about 35 megabits on the upload. Ping time, 33 milliseconds. For a server that is 900 miles away, that's quite good. And jitter here is 1.48 milliseconds. That's quite acceptable. I'm going to switch over now and show you a screenshot from my iPad where I ran the same test earlier. You'll see where I had 385 megabits per second download, but only 137 megabits per second on the upload. Ping was 10 milliseconds. This was to a local server in the southeast. That was very good. And my jitter, though, was a bit high at 9.83 for that particular test. The reason why you see a lower upload speed is because this is a single-threaded test. Also, it's just using standard HTTPS request. It's not doing any sort of fancy protocols or other transfer technology to try to maximize the numbers. It's basically a real-world web browsing type performance test. I think you'll consistently see lower upload speeds when you do run this test due to these limitations. But it's a great test. The source code is available. You can download it from GitHub. I wouldn't be able to decipher the code well enough to get any meaning out of it, but this is probably the most transparent test on the internet if you're wanting to know what goes on under the hood. A more robust test than LibreSpeed, if you're looking for saturating your high-speed internet connection, would be Nperf. Nperf is a totally ad-free site. When you visit them for the very first time, they're going to ask whether you want them to know your location. What's interesting, when you first visit the site, they give you a choice here of units. You can select whether you want to see your speed test results in kilobits per second or megabits per second or kilobytes or megabyte. That's very unique. I'll click here to go ahead and start the test. One thing I like about Nperf is that they have sort of a nice little motif here as far as a multicolored speedometer dial. I remember years ago, many internet tests were that way. AT&T used to have a whole car dashboard showing upload, download, and latency on different dials. But unfortunately, it seems like over the years, most speed testing sites have gotten rather boring in terms of their user interface. I'm connected to a server in Dodge City, Kansas, which doesn't make a whole lot of sense to me, but that's okay. It's giving me some good results here for my Wi-Fi connection. I'm getting about 71 megabits down and roughly 25 megabits up. Jitter is low at about 6 milliseconds. Latency is at about 70 milliseconds, and that's because I'm going up to New York City, and then for some reason it's routing me from New York City all the way to Dodge City, Kansas. And so that round trip of traffic is certainly a considerable distance. What's interesting here is even though I'm on VPN, and I can see that based on the IPv4 address here, this is definitely that New York server. Nperf knows generally where I am in Alabama. There are technologies out there that will trace you down to your location even if you're using a VPN. Again, for my purposes, I'm just using a VPN to conceal my IPv4 address. Fortunately for this example, that was still the case. Nperf offers a lot more than just a local speed test. You can click on their server selection and they've got servers all around the world that you can select. And what's kind of cool is they've got this globe that you can turn and run some long distance speed tests. If you want to run a speed test to some place like Jakarta, like we'll go ahead and just run one real quick just to see what kind of speed we're going to get. I suspect what we'll see is a reasonable download, but we'll see very high latency and possibly a very slow upload. We're getting excellent results from this server in Jakarta, nearly 70 megabits down, which is very good for my Wi-Fi connection. Sometimes the upload test takes quite a while to initialize on these long distance connections, and sometimes they don't even run at all. So now the upload is underway. It started out slow, but excellent, really. I'm quite pleased, even though we're running a speed test to a server on the other side of the world, we're getting some excellent numbers. I'm showing nearly 70 megabits per second download, which is as good as my Wi-Fi typically gets. The upload is around 19 megabits per second, which is very good considering we're uploading to Jakarta. And if we look at the latency here, it's very high, as I suspected, about 270 milliseconds. Jitter, 3.9 milliseconds. That's actually quite good. So again, with Nperf, you've got this massive server selection, and you can search also on a specific area. You can key in something like Tokyo, for example, and select Tokyo, Japan directly from the search list. Server selection seems to be richest in Europe and in South America. The North America server selection is somewhat limited. Nperf varies. We just got some excellent results from Jakarta, Indonesia, but you could also select other servers on their list in different parts of the world, and you may get very, very slow upload and download speeds. Again, it's always best to get familiar with the servers and tests that you like to run so you know what's normal before you can jump to any conclusions as to what is abnormal. Now we're going to check out MLAB. You may not have heard of MLAB before, but it is a commonly used speed test measurement engine. It's used by Google and by a number of ISPs for their own speed measuring test sites. I've gone out to a number of other more minor speed test sites, and I've seen a little notation on them saying powered by MLAB. When you run the MLAB speed test, you actually get two tests. At least I've been getting two tests every time I run it. They run what's called a network diagnostic tool test, which is their older test. It's basically a single threaded test. And then they run this new one called MSAT, which stands for Measurement Swiss Army Knife. And what that does is it runs a more modern multi-threaded test. So you're going to get sort of two for the price of one here whenever you kick off the MLAB speed test. And here you can see the pair of results. It used a test server out of Washington. Again, I'm on a VPN connection to New York City right now. The download speed for the single-threaded test was just over 68 megabits per second. The download speed for the multi-stream test was just over 70 megabits per second. The upload was also quite close, 30.7 megabits per second for the single streaming and 27 megabits for the multi-stream upload. Latency was the same, 7 milliseconds. And note here, they show packet loss, but they call it retransmission. So that's the MLAB test. They do have some additional information available. If you click on About MLAB, you can go into various documentation and things about the fact that they're open source and details about their technology. I haven't used this a lot directly, but again, you may find yourself using the MLAB speed test indirectly when you are going to other speed testing sites. I'm going to skip over Test by Net. Test by Net is a single-threaded test. I include it on my webpage because I think it's a good test if you're kind of an advanced speed tester and you want to set up some automated tests that run periodically. You can go to that website and learn how to work that site and set up some batches of tests that you can run. I'm going to skip down here to the not recommended sites, and I'm going to talk about why I don't like them. Speedcheck.org is the first one that we'll take a peek at. These are not malicious sites, but they're misleading. And I really do not like any sort of misleading marketing. I'm very much against deceptive marketing, and I'll show you what I mean here. So I'm running this speed test over a VPN connection to New York City. And I'm getting an accurate result. We're showing about 67 megabits down. The upload is in the 40 megabit range here, which is quite nominal for my connection. Latency seems quite high. I don't know why we're seeing such a high latency, but these numbers look good as far as the speed. Here's what I don't like. The security section here, connection unprotected. That is total nonsense. The internet, by default, uses HTTPS connections now. It's a secure, encrypted, endpoint-to-endpoint connection. So when you see something like connection unprotected, you have to be very, very suspicious. And all that is, by the way, I've checked, looked into it further. They're just trying to sell you a VPN service. The work environment is a different story, but for personal use, there's no need for VPN in this day and age with end-to-end encryption built in on the internet. I've been using a VPN as part of this video production simply because I want to keep my IPv4 address private. But for most users, there's no reason to use a VPN. I didn't even install a VPN for my own use until I was making this video. Additionally, speedcheck.org doesn't really give you any sort of server selection. It's really hard to know exactly if these numbers mean anything because you don't exactly know what server you're being measured against. You do want to do some reading about the internet speed test in general. They do have some decent documentation. Test by Speed is another website that I'm not found in. Oftentimes in this case, they do show a server location of Washington, U.S., but when they show us the final results, that information goes away. Look, the results of the tests themselves are not bad. I'm showing here 77 megabits down, and looks like we're going to get in the low 40 megabit per second range for the upload speed, and that's quite nominal. This is actually an excellent result, and this is what I don't like about it. It says your speed is poor, and that's not true at all. 8.1 milliseconds to a server in Washington, D.C. via New York, that's almost too good to be true. A jitter 0.1, that's excellent. I suppose they're looking at the average speed in my area and saying that my download speed is poor because it's only a fraction of my average speed. And this points out one of the reasons why I don't spend a lot of time looking at comparison metrics on the internet about internet speed. Anytime you run a speed test, you're simply measuring the weakest link in the system. As I run this speed test via VPN, goes up to New York, goes down to Washington, D.C., runs the speed test, brings the results back to me and stuff. That result is all limited by the entire round-trip connection, and that includes my Wi-Fi point. If I was running this same test within my home, just 120 feet away, I would see a result well above 300 megabits per second. But because I'm out in my man cave, I'm only going to get around 70 megabits per second. So here it's telling me my speed is poor, but in reality, that's not true. That's actually quite good considering the conditions. Additionally, 70 megabits per second is, I consider that a wonderful speed. You can stream 4K videos at the same time with 70 megabits per second. So I don't know where these qualitative descriptions of poor, good, and average, they don't really mean anything. Everything depends on your household size. Your latency is what really matters. An 8.1 millisecond ping time, if that's true, that's almost the best I've ever seen in my life, considering the connection involved. So where they come up with this speed being poor is a very strange conclusion. Again, this is one of the reasons why I don't like this website. You don't really know if you're hitting the same server when you run the test. A lot of questions, more questions than answers. Now that we've looked at a number of speed tests, let's cover some of the limitations and things to watch out for when running internet speed tests. Keep in mind that every test you run is just a snapshot in time. It shows a current condition, but doesn't necessarily reflect what the condition will be even a few minutes from now. Wide variations are always possible, especially when it comes to wireless connections. If you've got Wi-Fi, T-Mobile, or cellular connection of any kind, satellite connections involved, you're going to see variations, especially on time of day and even maybe from minute to minute, depending on the current congestion issues. In this video, I only ran like one test at each site. When I'm doing any sort of serious internet measurements, I'm going to run at least 3 tests. It's always good to run 3 tests, maybe space them a few minutes apart to get an idea of what the current condition really is. And as I've mentioned in the video before, and I'll mention now one last time, you're always measuring the slowest link in the chain. If you saw from my iPad screenshots versus what I've been running out here in my man cave, you'll notice a considerable discrepancy in results. I get around 70 megabits down, 40 megabits up out here in my man cave, whereas in my home it's around up to 370 megabits. It's not unusual. Speed tests, they measure your current state of your connection, but they don't tell you why or how relevant a result might be. You may be running a speed test and determine that, as I did, that your router, your gateway device, suffers from a condition called buffer bloat. But whether buffer bloat is relevant to your situation is another matter. In my case, I have a very bad case of buffer bloat with my AT&T router, but it's not important to me. There's just my wife and I in my household, and with our 375 megabit fiber connection, we do fine. We don't have a buffer bloat contention problem because of the way we both use the internet. A lot depends on your household and internet usage. The speed testing itself is just one tool. I've got Wi-Fi analyzers and other tools that I can run that measure the RF condition of my environment, so I can do additional troubleshooting above and beyond running a speed test. Many of these tools are free, and I may cover those in future videos if there is sufficient interest. As I've mentioned before, and I'll mention again, it's always good to run speed testing on occasion when everything is fine. And I would recommend specific site or two that you like. Don't run a speed test at an unfamiliar site if you're already familiar with the results from another site. In other words, in my case, I like to standardize around Ookla. I use Ookla as my primary testing site and then perhaps go to the other sites as a backup. Get familiar with what your equipment does, with what your environment does, with what your favorite speed testing site does. As you know, my website offers a number of speed testing sites. Find one that you like, stick with it as your primary speed testing site. Maybe have another one or two that you like to use as a backup. There are certain times when you don't want to run a speed test. Anytime where a speed test might create a problem with other users or with the system, you want to avoid it. For example, if you're in a hospital environment and Wi-Fi and internet are used for patient monitoring or operations, you don't want to be running a speed test there unless you know for sure that there's not going to be any negative impact on anyone else. Mission environments, whether you're working, if you're in some sort of critical mission situation for the military or NASA or whatever, there are times when you definitely do not want to run a speed test because a speed test will stress the network. If you're on a limited data plan, you definitely want to be careful. Out here in my man cave, when I run a speed test and I get my 70 megabits down, 40 megabits up, that has a low impact on data usage. But if you're running a speed test on a high-speed connection, 300, 500 gigabit connection, you can burn up a lot of data really fast. When you do run a speed test, be consistent, not only with the site, but with the equipment you're using, because a mobile phone and an iPad may give you a very different result depending on the type of Wi-Fi radios they have in them. Finally, I recommend rebooting your gateway device once in a while. If you go a long period of time between power outages and you're starting to experience some unusual buffering or other problems, and you run a speed test and you see less than optimum results, unplug your router. If there's no impact on anyone else, make sure that it's not going to mess up anybody. But I would power off your gateway device. In my case, with my AT&T router, I just physically unplug the power. I count to about 20 seconds or so, and then I plug it back in. It takes about 3 minutes for the router to reboot, reestablish its internet connection. But I have often seen, and by often I mean I do this 4 or 5 times a year, I've often seen this solve problems, bring back the speed I was missing. I've also seen where I think speed tests sometimes stress the router a bit. If you run a whole bunch of speed tests, say after watching this video, you go out and you start running all those speed tests from my website, you might want to reboot your router afterwards. It seems like to me the speed tests themselves can sometimes stress the router a bit and the memory usage. So feel free to, like I say, make sure you're not going to negatively impact anyone else on your network. But if you can, that occasional unplugging of the router, wait about half a minute, plug it back in, it can work wonders. Anyway, I hope you've enjoyed this video. I would love to point you to another video of mine, but this is my first video. So if you do like it, though, I hope you give it a thumbs up, and I hope to be making a lot more videos in the future. Thank you.